Hello, everyone. It's nice to come your way again with this mathematical challenge here. Here before us, we have a math challenge. If you look at this expression, it looks all familiar, though some of you must have seen this kind of mathematical expression. This is not a 2 to the power of 5. If it were to be 2 to the power of 5, there, the 5 will be written up here. And this is not 5 base 2. Okay? If it is 5 base 2, the 2 will not be as big as this. And so this kind of expression, we call them tetration expression. Okay, and tetration expressions are not common in our colleges. In fact, they are not included in the scheme of work of our university. Why? Because the figure that comes out of their expression from tetration expression are always very huge, very large figures, and at times some of them they can go out of control or out of range. And so we're only familiar with exponential equation, polynomial equation, quadratic equation, but that of tetration and Hessian equation, we are not familiar with them because the figures from there, they are too large to behold or to contain. Okay, and so we don't treat tetration equation like that in our school curriculum. But look at this question here. I dropped a challenge some time ago, and I said, if you want me to make a video on the next level of that expression, you should drop it in the comment section. And with number of comments I've seen so far, hence we are here today. Okay, if you've not watched that video, it's showing up here. Okay, you can click on the link and watch that video right now or after the watch of this very one. I'll also leave in the description below the first link to that video, okay, in the description where you can access that video. So let's go into today's challenge without much waste of time. So we take our selection here. All right, so the question reads 2 tetrated 5 plus 3 prime. Is this expression prime? If we evaluate this, and the figure we're going to get from here, is it going to be a prime number? So we're going to know from here. Now, the other way of rewriting this treated equation or tetration equation is this. This is same thing as our 2 to the power of 2 to the power of 2 to the power of 2 or to the power of 2. Okay? Or we can equally write this as our 2 to the power of 2 in bracket, there to the power of 2, bracket again, then to the power of 2, then bracket again, our 2. Okay, let's remove this very one. So 2 here. So we put this in bracket, include another bracket, and this other one here. Okay, so we're going to put another bracket here. So this expression we have here, 2 tetrated 5, could be written in this format or in this format. And like I said in that video, we want to start the simplification from the top expression here. And we add it to 3 and see if it will give us a prime number. We go to the next one, and the last one, if it will give us a number. I pray that the last one doesn't go out of range because here, the figure here is very huge. Okay, so we take the first one, which is going to give us our 2 to the power of 2 plus our 3. What will this give us? So we have here to be 4 plus 3, and this is 7. We know that 7 is a prime number. So the first expression, starting from this, plus our 3, this was a prime number. So we want to go down to this next one now. So we're going to have here 2 treated 3. Okay, so we're going to have here, let's write it in this format or in a simpler form. So we're going to have here 2 to the power of 2 to the power of 2 plus 3. This is equal to 2 to the power of 2 from what we see so far is 4. So we're going to have here 2 to the power of 4. So we're going to have 2 to the power of 4 there plus R3. This is equal to what? What is 2 to the power of 4? That is 16. So we have here 16 plus R3. And 16 plus 3 automatically will give us what? 19. You and I know that 19 is a prime number. So the second trial or the second step to our expression also gave us a prime number. Let's go to the third one, which is 1, 2, 3, the fourth one rather. Okay, so this fourth one here is going to give us here our 2 to the power of 2 to the power of 2 to the power of 2 plus R3. This is equal to, we'll see that 2 to the power of 2 to the power of 2, which is this expression we have here, is what? Is 16. So we're going to have here 2 to the power of 16 plus 3. So we now have here 2 to the power of 16 plus R3. But with this give us, this is going to give us a huge number. And so 2 to the power of 16, when imputing to your calculator, will give us 6, 5, 5, 3, 6. And so we're going to have automatically, and this is going to give us 6, 5, 5, 3, 6 plus our 3. All right, let's continue here. Okay. Now, if we add this to this, what would this give us? So we're going to have this to be our, this is equal to our 6, 5, 5, 3, 9. The question is this: is this a prime number? Yeah, when I check this, this is a prime number also. And so we can end up by saying that our 2 treated 4 is plus our 3 rather is equal to 6, 5, 5, 3, 9. This is also prime. This is a prime number. So look at the series here now. We'll check for this now. We've discovered that this is a prime number. Again, if we go ahead to check for 2 to the power of 1, that will give us 2 plus 3, that will give us 5. So that will also give us a prime number. So this is a prime number. This is a prime number. Okay, let's figure this out here. This is a prime number. This also is a prime number. And again, this is a prime number. Here comes the one we're looking for, which is 2 treated 5 plus 3. Okay, so let's write it out here. So we have here 2 treated 5 plus R3 will now be equal to what? We have already figured out 2 to the power of 2 to the power of 2 to the power of 2, which is what we have here to be 2 to the power of 16. And finally give us 6, 5, 5, 3, 6. So let's quickly write this. This is going to give us 2 to the power of 6, 5, 5, 3, 6 plus our 3. Here comes the problem. This guy gave a very huge figure. You now see the reason why I said tetration equations or expressions are not treated in colleges. They have to remove them from the scheme of work because they can easily go out of control. Now, if we simplify this, what will this give us? In fact, when I input this in my calculator could not carry the figure. And so I have to resort to my PC. And when I did that on my PC, this gave me a very huge figure, about 19,279 digits. That is very huge, very huge. And it started with 20035. So dash to 6 7, please. There 3 6. So plot our 3 here. So we have 1, 2, 3, 4, 5, 6, up to 19,729 digits. You can imagine that number. It took me time before I could figure it out. Okay, so from here, let's just quickly put it down. Yeah, this very guy here give what? 19,729 digits. Just from this. Okay, but this is the last 4 digits to this figure here, to this 19,000 digits, when we raise this to this. So if we add this to this, what will this give us? So this will end up giving us 20035 dash 6739. You get that? Okay, so we still have the 19,729 digits after adding our 3. All right, but from this question now, we have to ask ourselves, and I have to do a check. Is this figure divisible by any other number, or is not divisible by any other number? Or is it divisible by 1 and itself alone that will make it a prime number like what we are asked here? this figure is divisible by another number. Okay, so this figure is divisible by our 4, 2, 2, 6, 9, 2, 17. Yes. So it's divisible by this figure, yes. So long it's divisible by this, in other words, it is divisible by 1, it is divisible by 4,269,217, and it's also divisible by itself. That makes it not a prime number. So it's not a prime number, okay? Right? So from here, we cannot conclude by saying that therefore our 2 treated 5 plus R3 is not prime. Not prime. It's not prime. All right. So this brings us to the end of this math challenge. So how different from the normal mathematics we normally do on this channel, but at least we have to learn aside the box. We have to search for some other areas to broaden our level of understanding. Okay. Thanks for watching Online Maths TV. Again, if you notice any error in the process of this explanation, drop it in the comment section so that we can take amendments swiftly. And if you have a better way of expressing this figure, then drop it in the comment section also so that Online Maths TV can equally learn from you. Remember, we love you and we love you beyond the limit. Thanks for watching our content all the time. Till we meet you in our class again, don't forget to keep winning. Bye for now.